this is the first time we're going to be analyzing this graph and finding everything. We're going to find the intercepts, the extrema, the points of inflection. We're going to find the asymptotes. So there's a ton of things we're going to be looking for. And so I will create a list off to the side of those things that we find. Let's go ahead and just do them in order. Let's find the intercepts first. So we're going to find the x-intercept, and I'm going to be writing really small because there's a ton of things we're going to be doing on this slide. And when I compute the x-intercept, I will find that it occurs at 0, which means that I have an intercept of 0, which means that my y-intercept is also 0. So one of the things that's on my graph, and I'll just kind of make a list here on my graph. This would be important points. 0, 0 is an important point. It's an intercept. Looking at the next thing we're going to find is relative extrema, and we know that those occur at the first derivative. So we do need to find that first derivative, so I'll start to do that right here. I have to use a quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. This ends up giving me 2x cubed plus 6x minus 2x cubed all over x squared plus 3 quantity squared. Those cancel, and I'm left with 6x over x squared plus 3 quantity squared. Remember, I'm looking for places where the bottom gives me 0, so where critical numbers would be where the bottom gives you 0, which there is no values, or where the top gives you 0, which, once again, we get x equals 0. Where I found out that x equals 0 is the intercept, well, it happens to also be a critical number. What that means is that we're going to have to test this interval. So y prime, we're going to test 0. We're going to plug in and find out what's going on with the slopes of the tangent lines. Well, when I plug in 1, I end up with a positive, and over here, when I plug in negative 1, I end up with a negative. So that means it's decreasing and then increasing here. It's decreasing and increasing. I now know that 0, 0 is a minimum. I will continue this with the next video. Alright, the next thing we're going to do is find, since we found our relative extrema, we're going to go ahead and find the points of inflection. So the points of inflection occur at the second derivative, so we're going to go ahead and try to fit the second derivative onto this page. So here's my first derivative right here, and so I'm going to have to do a quotient rule again. Bottom times the derivative of the top minus the top times the derivative of the bottom. And I need another 2x in there, barely squeeze that in, all over bottom squared, so that now means it's to the 4th power. So what that ends up giving me is I have the 6x squared plus 3 squared minus, I have 6 times 2, which is 24x, and I have an x squared plus 3. That is not going to be easy to set equal to 0. So what I'm going to try to do is, since these each have an x squared minus 3 on top, hopefully if I just change colored pens you guys can see, I'm going to simplify this, make this a 1. I'm going to take out an x minus 2 out of each of these, and that would make this one a 3. What's that leave me with? Well, it leaves me with my second derivative being 6x squared plus 18 minus 24x. Oh, and I left off this should be a squared right here. This should, x times x is an x squared. I knew something was a little bit off. I apologize. So I did 6 times 2, which is 24, and x times x, which is x squared. And then I factored out an x squared minus, or x squared plus 3 on each of these. And so this ends up being squared. On the bottom, I have x squared plus 3 to the 3rd power then. So a little bit more simplifying here, I get negative 18x squared plus 18. Much easier to set equal to 0. The bottom will never give me 0, so I don't need to look for that. So if I set the top equal to 0, I end up finding out that when x is 1, there's a point of inflection. And I lost my squared again. So this would be plus or minus 1. So we're going to analyze the points of inflection. That would be using the second derivative. We're going to do some plugging in of numbers. So if I put in 0 up here, I end up with a positive, meaning it's going to be concave up. Over here, if I put in a negative 2, I do get a negative value on top and a positive on the bottom. And if I plug in 2, I get another negative value over here. So I do have a couple of points of inflection. I can find those points of inflection by plugging those back in. So on my graph, I have the 0, 0, min. I also have points of inflection of 1 comma something and negative 1 comma something. I have to figure out what those are by plugging them back into the original if I want the actual point values. So I end up with 1. This would be 1 over 1 plus 3, so it would be 1/4. And if I plug in negative 1, I end up with 1/4 again. So now that I've found each of those things and I know my concavity, I will be able to create a graph. Well, the one thing I didn't do is asymptotes yet. Sorry about that. I told you these were really, really long problems. Well, I know that 0 will never occur on the bottom, so there is no vertical asymptote. I notice that the degree on top is not 1 higher than the bottom, so there's no slant asymptote. But if I can squeeze it in right here, there is a limit as x approaches infinity of x squared over x squared using L'Hopital's rule. I found out 1. So I do have a horizontal asymptote at y equals 1. I will squeeze in here my ordered pairs. So here's 0, 0. I've graphed that one. 1 and 1/4 right here, and negative 1 and 1/4 is right here. It says it's concave up between negative 1 and 1, so there's my concave up. It says it's concave down from 1 to infinity and concave down from negative 1 to infinity. And if I look at my increasing, decreasing, this does decrease and then it does increase, so I can feel confident in my sketch.